All right, today, ladies and gentlemen, we're going to talk about single replacement reactions. Now, with our single replacement reactions, our learning target is to, once again, classify the types of chemical reactions. This is our third of the 5 total. So this is the third one, single replacement. So our success criteria is going to be to balance a chemical equation, to describe/identify a single replacement reaction, and to predict a single replacement reaction. So one more, my bad. Use the activity series to predict whether a single replacement reaction occurs. That's why I said you're probably going to want to have out your activity series too. Okay? So, a single replacement reaction, the general format is element A reacts with compound BC. The A replaces the B. So I have compound AC in my products, and I have element B. So basically, the way I used to describe this is, let's say a guy is dancing with his girlfriend at the homecoming dance, and then somebody comes in and cuts in. Well, the new guy is now dancing with the girlfriend, and the old guy is out. He's out. He's done. So that's what we have happening almost like in a single replacement reaction. We must use the activity series. For element A to knock out B, it has to be more active. So it has to be higher on the activity series. So when I look at my 5 different single replacement reactions, we can see some certain things that are happening, and we're going to use this right here to help us identify when we're talking about which type of a single replacement reaction. So the first one we are going to work is right here. Sodium oxide plus calcium. So go ahead and copy that in your note. Now, the first thing we need to do is we need to determine which type of a single replacement this is. So I have basically a metal oxide and a metal, correct? So when I come back here, actually, let me go back. A metal oxide, okay? So that's a salt. That's ionically bonded. And calcium is a metal. So when I go back, I look and I say, okay, a metal and an aqueous salt. That could be. Do I have an active metal in water? I do not. I do not. So I can rule out number 2. It could be number 1, rule out number 2. Do I have a metal and an acid? I don't have an acid. Do I have a halogen? What's a halogen? Group 17. Do I have a group 17 element on here? No, I do not. Do I have a metal oxide and hydrogen? Well, I have a metal oxide, right? Is it with hydrogen? No, it's with calcium, correct? So we've got here a single replacement number 1. So I'm going to put up here SR number 1. So on a SR number 1, okay, what I'm going to do first is I'm going to write out sodium oxide. Na2O plus calcium. Because I'm going to see if the calcium will actually replace the sodium. So to do that, I'm going to pop this here. I'm going to come here. Here's my activity series. So I look at my activity series. Okay, I sit down my blue pen so that I can move it. I look at my activity series and I say, okay, will calcium replace sodium? Well, look right here. Who's more active? Calcium. So will calcium replace sodium? Yep, absolutely. So when I come back here to my PowerPoint from my current slide here, my calcium's going to replace sodium, so I know it's going to work. So I'm going to get a new metal and a new salt. Well, I'm going to start off with my new metal because I know my new metal is going to be sodium. And that leaves me with my new salt is going to be, so I'm going to get sodium, and I'm going to get calcium oxide. So here's my sodium, calcium oxide. Calcium's a group 2, so it's a 2 plus. Oxygen is going to be group 16. It's going to be a 2 minus, so that's going to be CaO. Now, as I'm looking at that, Matthias, am I balanced? I am not. Why am I not? Because my sodium is off. So, if I put a 2 there, am I now balanced? Yes, I am. So, ladies and gentlemen, that's our first single replacement reaction. Here's my second one. Iron plus copper 1 chloride. So once again, I am going to go through. I have iron, I have copper 1 chloride. Looking at my chances, my 5 single replacements. It could be a number 1 because I have a metal and an aqueous salt. Do I have an active metal and water? I don't see any water there, do you? So I can count that out. Do I have a metal and an acid? Do you see an acid? I don't either. So I can count that out. Do we see a halogen in this one? Well, chloride is a halogen, but let's go back and look. It has a halogen by itself plus an aqueous salt. Does that fit the bill for this? No, that halogen is not by itself. A metal oxide and hydrogen. Well, I don't see hydrogen. I don't see a metal oxide. So once again, this has got to be a single replacement number 1. So I'm going to put SR number 1. I'm going to say Fe is with copper 1 chloride. Now, it tells me right here that I'm going to get a new metal and a new salt. Well, what's my new metal going to be? Well, whoa, I better check, huh? I better check. Does iron replace copper? Is iron higher than copper? Well, let's come back here. Let's get this off of here, and let's look. Let me sit my pen down. Let's look. Let's find copper and iron. Well, here's copper. Here's iron. Is iron going to replace copper? Yes, it will. It's higher on the activity series. So iron will replace copper. So my new metal is going to be Cu. I can't take that C. Cu is going to be my new metal. What is my new salt going to be? Well, it's going to be iron chloride. Now, what do we know about iron? It's multivalent. Does it tell me what iron this is going to be? No, so I would have to do testing. So if this something like this were on a test, you could use any iron you want. Now, for right now, I'm just going to use iron. Well, I can't use iron 1 chloride because that doesn't exist. I'm going to use iron 2 chloride. All right. So, my iron 2 chloride, my copper right there. Marquez, do you think that this is a balanced equation? No, it is not. Why not? The chlorines are off. So I've got to put a 2 here. If I put a 2 there, then I'm also going to need to put a 2 here. Okay? Now, let's see what would be different. Let's see what would be different. Fe plus copper 1 chloride. Let's say that I use iron 3. So I'm going to have FeCl3. Now, what's going to be different here? What do you think, Lillian? Right, it's just going to be balancing a little bit different. So right here, I'm going to have a 3 here for 3 chlorines. Then I'm going to have to put a 3 here to give me 3 coppers. Correct? Any questions on that one? So, sometimes we specifically don't know which particular one it would be. Now, what I am going to show you here, okay, before we move on, I'm going to pause it here a second. All right, here's our next one. Chromium and steam. Now, what is steam? Huh? It's just water, isn't it? So, I'm thinking here, all right, I got steam, I got water. So this is basically chromium and water, but I can say that it's in the gaseous form. I can say that it's in the gaseous form. Now, as I come back here, I remember something about water right here in number 2. So, as I look at this, I say, okay, do I have an active metal? Do I have an active metal? Because I'm thinking that this is a single replacement number 2. Well, I need to go back to my activity series here, okay? And I see right here that there's a line that says, reacts with steam, liberating hydrogen gas. That means giving off. Liberating means giving off. So, does this fit the bill? Is chromium above that line? Is chromium above that line? It is. So, as I come back and look and say, okay, chromium is above that line, so I do in fact have a single replacement number 2. There's my hydrogen that's liberated. Here's my salt. It is a metal hydroxide. So, what is my metal hydroxide going to be? I'm going to get chromium hydroxide. I'm going to get hydrogen. Now, what do we all know about hydrogen? It's the super 7. So it better be an H2. So, once again, chromium. Chromium can take many charges, right? I look up here on my periodic table. I see chromium has a 3, a 6, and a 2. What I am going to do is I am going to use chromium 2. So, chromium is a 2 plus. Hydroxide's a polyatomic. It is a 1 minus. I put that box around it. Remember, back to nomenclature. I put that box around it. So now I got chromium. I need more than one hydroxide. So I got chromium, parentheses, OH, end of parentheses, 2. And then I've got my hydrogen. Now, Brooke, what you thinking? Am I done here? No, I'm not, because my H's are not balanced. I have 2 here, and I have 2 here. That's 4 total. Well, doesn't it fit real nice here? If I put 4 here, now I've got 2 oxygens. So my chromiums, I've got 1. Hydrogens, I got 2 times 2 is 4. 4, and my oxygens, 2 and 2. Now am I balanced, Brooke? I am. So now I have a balanced chemical equation. And this was a single replacement. I believe I said number 2, right? Single replacement number 2. Any questions? Here's our next one. Zinc and hydrobromic acid. Now, somewhere in my mind, I'm remembering something about an acid. An acid. How about right here? An acid. So I'm thinking right now that I'm dealing with a single replacement number 3. Okay? Now, single replacement number 3 says that a metal and an acid will give a salt dissolved, and it will also give hydrogen gas. Okay? Now, what I need to do is I need to come back to my activity series. And here, reacts with acid, liberating hydrogen gas. What was my metal that was trying to replace? What was my metal that was trying to replace? Zinc. Oh, is zinc above that line? Yes, it is. So zinc will replace. So my metal and my acid is going to give me a salt. Well, what's my salt going to be? Well, I have hydrogen and bromine. So what's my salt going to be? It's going to be zinc bromide. And I'm going to liberate hydrogen gas again. So as I start to put together this, and I better put up here, single replacement number 3, I'm going to have zinc plus hydrobromic acid, ICIC 1 or 3. Oh, here's the hydro. That's acid rule number 1. So I have HBr. That's hydrobromic acid, acid rule number 1. Now, zinc bromide. Zinc. I look over here at my my periodic table. Zinc is a 2 plus. Bromine, halogen, 1 minus. So zinc bromide is going to be Zn Br2. And then I have this H2. Cameron, am I balanced? No. How do I balance this? I need to put a 2 in front of the HBr. And now is it balanced? Absolutely. Okay. Absolutely. Any questions on that one? Moving on, moving on. Here's our next one. Bromine and sodium iodide. Bromine and sodium iodide. Now, what do you know about bromine? Anything? It's what? It's a halogen. Well, don't I have something right here that says a halogen with an aqueous salt? So, this is going to be a single replacement number 4. Now, when you're dealing with a single replacement number 4, you should have all kinds of bells ringing in your head. Why should you have bells ringing in your head? Well, you're going to look all up and down this activity series right here, and you're not going to find the halogens because they are right here. So a halogen is going to replace another halogen. So as I look back here, my halogen, bromine, is going to replace my other halogen, which is iodine. So I have to see, is bromine going to replace iodine? Yes, because it's higher. It's higher. So bromine will replace iodine. So I have bromine replacing iodine. So iodine's going to be kicked out. And I'm going to also have sodium bromide. That's going to be my new salt. So bromine. Remember, when I'm dealing with these halogens, that they're all super 7s, right? So bromine is going to react with sodium iodide. We already said it's kicking out the iodine. Iodine's a super 7, though. And it's going to give me sodium bromide. Allie, am I finished? Nope. What do I need to do? Excellent. I did not have a balanced equation. Now, do I have a balanced equation? I do. I do. Excuse me. Water and sodium. Now, once again, I remember having this water right here. This water. Now, is that water the same as I had before, steam? No, water's in the liquid form, right? So I'm going to go to my activity series once again. Now, if I look at this, I have two different lines here that I need to notice. Reacts with steam, liberating hydrogen gas. That's the one we worked before. Here's one that reacts with cold water, liberating hydrogen gas. Now, sodium was my metal. Will sodium react with cold water? Yeah, because it's above that line. So yes, indeed, this reaction is going to occur. So I have a single replacement number 2. So it's going to give me a metal hydroxide, which is going to be sodium hydroxide and hydrogen gas. So as I'm going to come through and write my equation, water is H2O. I'm going to put it in the liquid form. Sodium. It's going to yield sodium hydroxide. Na is a 1 plus. OH. Polyatomic 1 minus. NaOH plus hydrogen gas. Now, am I balanced? Christoph? No, correct answer. Okay? Because I can see right here, I have 3 hydrogens. I need to have an even amount of hydrogens. So now I have 2 hydrogens, 4 hydrogens, and 2 oxygens. How about 4 hydrogens and 2 oxygens? Yes. So that leaves me with, just putting that 2 in front of sodium. Now I have a balanced chemical equation. Our next one. Copper plus iron 2 nitrate. Well, as I look back, I don't have hydrogen there, I don't have a halogen, I don't have an acid, I don't have water. So I'm looking, this has got to be a metal and an aqueous salt. So this is a single replacement, number 1. Now, I've got to look to see if copper will replace iron. So I go to my activity series. I find iron. I find copper. Will copper replace iron? Copper's not nearly strong enough to replace the iron, is it? Okay, so when I go back here to my PowerPoint, will copper replace iron? No, it will not. So I can just simply put no reaction. Okay, because the copper is not going to replace the iron. It's not strong enough. Okay, back onto this. We got one more here to do. Zinc and sulfuric acid. Once again, in your mind, you should have a little bell ringing saying, hey, one of my reactions is dealing with an acid. Whereas, oh, here it is, number 3, a metal and an acid. Well, I'm going to check just in case. Do I have a metal? I do. Okay. Is it above the H line? H line reacts with acids. Is it above it? It sure is. So will this reaction occur? Absolutely. So this is a single replacement number 3. Now a single replacement number 3, zinc and sulfuric acid, is going to give me a salt and hydrogen gas. So what is, let me get this caught up, zinc, ICIC 1 or 3, this is acid rule number 3, sulfuric gives me sulfate, sulfate, H2SO4. Now, what's my new metal going to be? Well, it's going to be zinc sulfate and hydrogen gas. Remember, hydrogen's a super 7. So zinc is a 2+. Sulfate's a polyatomic, SO4, 2-. So the charges cancel. So it's going to be zinc, sulfate, hydrogen gas. I look at this Carly. Am I balanced here? Yes, I am. Yes, I am. So that is my final answer. Any questions?